Just Michael? Yeah. Hello?
Hello.
Okay, so anyway. Alright, so 7.6, approximating integrals, trapezoid rule, trapezoid sum, Simpson's rule. So this one should be pretty easy. I'm going to show you guys how to do this, and it's going to be pretty basic. Alright, trapezoid rule, blah, 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 continuous, blah. Okay, so now what I'm going to do is I'm going to show you guys one basic. So I'm going to start off this. So I'm going to call this one A. I'm going to call this one B. I'm going to call my function here. Okay. So area of a trapezoid. So if I'm looking at the area of a trapezoid, I'm going to do this one in black to do my basic trapezoid shape. So, area of a trapezoid, 1/2 my, so it's going to be, yeah, so it's like B1 plus B2 times the height. Okay, so now we're going to actually use this formula and turn it all into some type of equation for the trapezoid rule. So if I'm looking at this one, my B1 is from my A, right? That's like my f of A. That's the value from here to here, right? Yes? Okay, my B2 is f of B, isn't it? That's this value right here, right? The height is going to be here, isn't it? All right, so let's see. How do I figure out the height? It should be B minus A, right?
You don't have to divide it.
We're doing just one right now, just to actually try.
N equals 1, so then they would still hold true.
Okay. Okay. Thank you. So I'm gonna have 1/2
X equals
of
Make sure to add A.
B
Because A equals
minus A, right? Okay, so, and this is going to be divided by how many sections we're going to have, right? So, my delta x in this case, which he was so gracious to point out, we're dividing it by how many we would have, right? So, he wants to put in the n, but I'm not ready to put in the n yet. We're going to have an n over here. So, right now that's just one, because I have one trapezoid. So I have that. That's going to be my height, isn't it? So I've taken care of the height. I've taken care of the half, right? And so this is going to be times my function, which is going to be f of A plus f of B. Okay? That makes sense now, right? Now, I'm going to divide it up a little bit more now. So with this one basic, we have the basic of my formula here. This is just like the simplest version. The simplest version of it just for one trapezoid, right? But now I'm going to cut this up into more pieces. Okay. So how many of those pieces do I have now? I have 5. So now, since I'm going to have my entire delta x, right, is b minus a, right? But now for this to be equal thickness, for every single one of those, it's going to be that divided by 5. Or in my case, how many that I want to divide by n being my equal parts. So this is going to be my n. Okay, so I'm changing this now to my n. So that's going to be how many parts I have. Now, I'm going to redo my function. So now it's going to be b minus a over 2n. So there's all that. Times. Okay? So now we're going to do each one of these, all right? So this one's going to look pretty interesting. But then it will clear out really nice when we're done. So let's take a look at my first one. My first trapezoid is going to be the AB, right? So it's going to be from here to here, right? So it's going to be this one plus this one, right? So it's going to be f of A plus f of C, right? Okay. Plus, now my next one, right? Which is going to be f of, right here, the next one, let's look. F of C again, isn't it? F of C plus f of D, right? Does that make sense?
Yeah.
I'm just talking about this piece right here. Oh. My camera shifted it up. Okay, so I'm only talking about C to D. So it's only talking about this piece now. Right? Are you okay? Speak.
Okay.
Okay. Okay, my next piece. This is going to be f of D, right? So it's f of D plus f of E. And keep going, right? F of E plus f of F, right?
Yeah.
Plus f of F plus f of B. I probably should have done, less parts, but let's see if you can get the pattern out of this.
F of A plus 2 and C plus 2.
Now, how many f of a's do I have?
Oh,
Okay, so this is, I'm going to rewrite this now. So this is going to be my final. So it's going to be b minus a 2n. It's f of a plus, anything else I only have one of? F of b. So I only have front, so the top, so the first one and the last one's only one, right? F of b plus. Now, I have 2 of these, right? And I have 2 of those, right? 2 of those, right? And 2 of those, don't I? Yeah? So since I have 2 of those, for all of those, do I want to keep writing those over and over again? No, I'm going to go 2 times my f of C, f of D, f oh wait, it should be a plus sign. F of, where am I at? C, D, E, F of F. So now, you guys notice the pattern? You guys got the pattern now, right? So it's b minus a over 2n times quantity of my first and my last plus 2 times all the ones in between. You guys sure you got it? Okay, let's see if we can do it now. Use trapezoid rule with n equals 4, n equals 6, approximate from 0 to pi, sine x dx round to 3 decimal places. Okay, let's see if we can actually do this now. So it's going to be b minus a should be minus 0 over 2 times 4, right? So f of what? A, which is 0, plus f of pi plus 2 times. Now, for this next piece, I have to try and figure out my parts, right? So I still have to do my b minus a divided by n. So it's going to be pi minus 0 over 4, which is pi over 4, right? So that's my increments. That's my thickness. That's my delta x, and I'm going for each one of these, right? Okay, so each one's going to be pi over 4. So now, starting at pi, this next one's going to be f of... Oh, I'm sorry, starting at 0. Thank you. So starting at 0, it should go 0, pi over 4, right? Yep. Then the next one's going to be plus f of pi over 2 plus f of 3 pi over 4. You're right. 3 pi over 4. Is that my last one?
Yeah, and it goes back.
Yeah, then it goes back to just pi, right? It goes 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 over 4. 4 over 4 is my pi. That's my end. There. Bracket. Does that make sense? Okay, good. So now let's do this. So it's going to be pi over 8 times my function f of 0. So sine at 0 is 0 plus 0 plus 2 times f of pi over 4, rad 2 over 2. Plus 1 plus rad 2 over 2. Uh, 2 rad 2 over 2, which is just rad 2 times 2. So it's going to be pi over 8 still times, that means 2 rad 2 plus 2. Times pi over 8, which is going to be pi over 4 plus, what's that going to be? Pi, yeah, pi rad 2 over 4. All right. Remember that vars in your calculator? Yeah, you want to put the sign in there? Put sine x, and x makes this a whole lot quicker. There we go. All right. Put my sine x. Okay, there we go. Get back out. So we said, what was it, just pi over 8?
Yeah.
Let's see, my function, which would be vars, right? At 0, close,
plus bars at pi, close, plus 2 parentheses vars at pi over 4, close, plus bars, where are we at, pi over 2?
Yep.
And 3 pi over 4. There you go.
You're in degrees.
Somehow that's his computer.
No, it says radian.
Stupid tree.
There you go.
When you're in bed.
3 decimals should be 1.896. So 1.896. Let's see if my by hand math came out to be the same. Power 4. And it was a plus pi we're at 2. Hey, look, it's there. All right, so I basically did the same thing on both. I got the same answer. You can do this by hand. It's kind of a pain, but it works every time. I don't like trying to teach you guys the formula. I'd rather teach you guys how to make the formula, and you have to make it yourself each time. And compare that to approximation exact value. All right, so let me see. Integral from 0 to pi of sine x, what do we get?
2.
Should be just 2, right? Two. Yep. Close. Not there though, right? It's another way of typing in approximations. Alright, do I need to do the 6th one also? Say no.
Probably.
Yes? You want me to?
We got the gist.
What about this one? This one's ugly. I don't want to do this one. Okay, let's try this one now.
We got like 1 minute.
Oh, there's just 1 minute left? Wait, no, we got 3 minutes. Hold on, let me see.
He said just a minute?
Error.
Just enough.
No. No. Oh, this was actually, this one right here is actually probably one of the better ones right here because you're going to get it from the table. And the tables are not always going to be uniform. Their delta x is not going to be uniform. So you're going to have to actually try and figure it out from here to here. So from here to here. So each one of these is not going to be like you're factoring out that delta x from each one. So you're going to have to actually get this one. This one is uniform, but sometimes they're not. Let me see. 1, 3. Yep, this one's not uniform. Okay, this is important right here. Okay, example 6. Crap. Should I do? When should I do this one? Guess I'll do it tomorrow.
Yeah.